Hey guys, welcome back to a new video by Biology with Zangshan. So today we're going to do the 0610/61 May-June 2023 paper 6 alternative to practical. So the link of this paper will be again in the description box below and make sure you check it out. So let's start off with the video. Okay. Question 1. A student investigated the effect of temperature on the rate of respiration in yeast cell. When yeast cells respire, they release carbon dioxide gas. The student used this method. Step 1. Fill a syringe with 15 cm cube of yeast suspension. Step 2. Gently lower the syringe into the measuring cylinder as shown in figure 1.1. Step 3. Fill the measuring cylinder with hot water. Ensure the water level in the measuring cylinder is above the syringe nozzle. Okay. Step 4. Measure the temperature of the water in the measuring cylinder. Step 5. Start the stop clock and wait for 2 minutes. Step 6. After 2 minutes, reset the stop clock to 0. Step 7. Start the stop clock again and count the number of bubbles produced by the yeast suspension in 3 minutes. Step 8. Pour the hot water in the measuring cylinder into the waste container. The syringe containing the yeast suspension should remain in the measuring cylinder. Step 9. Fill the measuring cylinder with cold water. Ensure that the water level in the measuring cylinder is above the syringe nozzle. Step 10. Repeat steps 4 to step 7. Figure 1.2 shows the thermometer during step 4 and step 10, so which is shown as 42 degrees and 18 degrees. Figure 1.3 shows the number of bubbles the student counted in 3 minutes in step 7 and step 10. So hot water have 54 bubbles, cold water is 12 bubbles. So what does this mean is that when we are doing the table, hot water will be the 42 degrees, okay, and the cold water will be the 18 degrees. So part 1, prepare a table for the result and record the temperature shown in figure 1.2 and the result shown in figure 1.3. So just draw this simple table and just fill in the data. Part 2, state a conclusion for the result. So the higher the temperature, the greater the rate of respiration or the number of bubbles in 3 minutes. Part 3, using the results, calculate the rate of bubble production in bubbles per minute. So this is 1 minute, yeah, for the yeast suspension in hot water and in cold water. So the data they give us is that it's counted in 3 minutes and they want to find 1 minute. What you have to do is by dividing by 3 divided by 3, which you get 18 and 1 is 4. 18 and 4. So the answer is 18 and 4. And thus you're working in the middle. Part 4, state the independent variable in this investigation, the temperature. You know why it's the temperature? Because they said that the effect of temperature, that is the IV. Alright. And part 5, state two variables that were kept constant in the investigation, the volume of yeast, the concentration of yeast. It's the same thing all over again. Part 6, suggest why the yeast suspension was left 2 minutes in step 5 before starting to count the number of bubbles. It is to ensure the temperature of water is the same as the temperature of the yeast, an idea of equilibrium. Okay. Part 7, suggest why counting bubbles is not the most accurate method of determining the rate of respiration in yeast, because the bubbles, right, there could be small, it could be big sizes, and the volume can change. So therefore bubbles can vary in sizes. Alright. B, measuring the volume of gas is more accurate than counting bubbles. Using a gas syringe is one method of collecting a volume of gas. Figure 1.4 shows part of the apparatus that can be used to measure volume of gas by a different method. So complete the diagram in figure 1.4 by drawing and labeling two pieces of apparatus that are missing. So one is a delivery tube and one is an inverted measuring cylinder. Okay, part C, yeast can respire reducing sugars. Describe the method you would use to test a substance for presence of reducing sugar. So using Benedict solution and heat it up. Okay. Part D, bread is made of flour, okay, water and yeast, which are mixed to form a dough. Figure 1.5 shows a person making bread. The carbon dioxide gas produced by yeast causes the volume of dough to increase. Sodium chloride salt is often added to dough when making bread. The sodium chloride affects the rate at which the yeast respire. Plan investigation determine the effect of the mass of the sodium chloride on the volume of dough. Okay. So prepare the apparatus for this investigation. There will be different methods of salt prepared: 2 grams, 4 grams, and 6 grams of salt, and it's measured accurately using a balance. The volume of water and concentration of the yeast plus the type of flour used will remain the same throughout the investigation. The results can be determined by the time taken needed to reach a certain height for the dough. To find out which mass of salt is better, yeah. So the investigation will be repeated 2 or more to ensure a fair result. Okay. Part 2, question 2. Figure 2.1 is a photograph of a cross-section of a root from a carrot plant, Daucus carota. So part 1, draw a large diagram of the carrot root cross-section that shows the layer visible in figure 2.1. So 4 marks is outline a single line, size at least 109 millimeters, 3 or more layers, white line layer with a point at 9 o'clock direction. Okay. Part 2. Line PQ on figure 2.1 represents the diameter of the carrot root cross-section. Measure the length of line PQ in figure 2.1. So using a ruler, and then measure this P to Q line, and you make sure it's in millimeters. So it's 109 millimeters. Now they want you to calculate the actual diameter. So using the formula, I image length over magnification will be 109 over 6 equals to 18.1666, which when you convert it to one decimal place will be 18.2 millimeter. B. A student investigated the effect of the concentration of a salt solution on the mass of carrot cubes. The student used this method. The carrots were cut into cubes. Each side of the cube was 1 centimeter in length. The initial mass of each carrot cube was measured and recorded. Each carrot cube was put into a different concentration of salt solution. The carrot cubes were left in the salt solution for 1 hour. After 1 hour, the carrot cubes were removed from the salt solution and dried with a paper towel. The final mass of each carrot cube was measured and recorded. Part 1. State the dependent variable of the investigation described in 2b, the mass of the carrots. Part 2. State 2 variables that were kept constant in this investigation: the type of carrots and the size of carrots. Part 3. Explain why it was important to dry the carrot cubes before measuring the final mass, because the water is also counted in the measuring mass process. Okay, now they say the result of the investigation are shown in table 2.1. This is definitely a graph question. So part 4, using the data in table 2.1, plot a line graph on the grid to show the effect of concentration of using salt solution on the change of mass of the carrot cubes. One axis has been done for you. So you just basically have to plot your data from the concentration of salt and the change in mass, and make sure your units are written down. And just draw the graph. You can pause the video to have a look at it. Part 5, using your graph, estimate the concentration of salt solution at which there's no change in the mass of the carrot cube. Show on the graph how you obtain your result. So you can see on 0.22, I have a line there, okay, which is 0.22 mole per dm cube. Last question, using the information in table 2.1, calculate the percentage change in mass of the carrot cube that was placed in the 0.4 mole per dm cube salt solution. The space is working, which is minus 6.25%. Last part, the student did not repeat the investigation, only collected one set of results. Explain why it's better to collect several sets of results. Because it is easy to identify anomalous result. Alright, so that's all for this paper. So hope you guys love this video. See you guys in the next video. Bye bye.